Welcome to the Backpacking Light podcast, where we discuss the philosophy and skills of traveling light so you can experience the outdoors with more comfort, more safety, and more enjoyment. I'm Ryan Jordan.
And I'm Andrew Marshall, and we are your hosts on this lifelong journey of doing more with less as we venture into wild places and empty spaces.
Look for me in the mountains where walking has a way of pulling you to your peace of mind every day.
Today's episode is about Dyneema Composite Fabrics, formerly known as Cuban fiber, which comprises a family of fabrics well known in the lightweight backpacking community for its very high strength to weight ratio. It's commonly used in shelters and backpacks, but we also see it in other applications, including waterproof breathable apparel, accessories such as stuff sacks, and even in inflatables like a pack raft.
So today we're going to get into the heart of how Dyneema composite fabrics are made, what their strengths and limitations are, which fabrics are best for different applications, and we're also going to explore some of the more controversial issues surrounding these fabrics, including their very high pricing and some of their assumed performance limitations.
I'm kind of excited to get into some of this controversy.
Yeah, me too. And I really hope we're able to clear up some of the confusion surrounding these fabrics and maybe dispel some of the myths that are being propagated about them.
So we've interviewed a number of guests for this podcast, including Henry Shires from TarpTent, Mike St. Pierre of Hyperlite Mountain Gear, Joe Valesko from ZPacks, Graham Williams of CiloGear, and Glen Van Peski from Gossamer Gear. So we'll be playing excerpts from those interviews throughout the podcast to help us create a bigger picture view of DCF and its role in backpacking gear.
But first, we should probably establish exactly what DCF means because this can get a little complicated.
Yeah, so DCF is the acronym that we are going to use today to describe Dyneema Composite Fabrics, because having to say Dyneema Composite Fabrics over and over is going to be a mouthful. So we're just going to call it DCF for ease. So a brief history is in order here. Back in 1997, the Cuban Fiber Corporation started producing these high-performance sailing fabrics that offered much higher strength to weight ratios than anything ever seen previously in the sailing world. And the fabrics had been kind of custom made since the early 90s, but now we had a company that was going to make them on a larger scale. They were laminates of hand-laid Dyneema fibers sandwiched in these monofilament level films. The primary performance benefit here was the lack of stretch of these fabrics as a result of these ultra strong, low stretch Dyneema fibers. And so this made for extremely stable sails, which is a huge performance benefit for sailing. This happened about the same time ultralight backpacking started becoming a thing on the internet, and a lot of the old make your own gear guys were making stuff sacks and tarps out of other types of sailing and parachute cloths. They were using silicone impregnated nylons and polyesters, the kinds of fabrics that were going into spinnaker sails, and then posting their designs online. So anyway, the Cuban Fiber Corporation was discovered by some of these guys. And by 2003 or so, a bunch of us were experimenting with Cuban fiber fabrics for backpacking gear.
And you did some of this too. What was the first Cuban fiber product you made?
So I purchased my first batch of Cuban in late 2002 and started fiddling around with stuff sacks. I replaced a floor on my bivy sack to save a bunch of weight. I even made a vapor barrier shirt. And then by the summer of 2003, I built a tarp. And this was the first prototype of the tarp that would eventually be sold under the Stealth Tarps brand that was sold at Backpacking Light between 2004 and 2011.
So just as a frame of reference for those people who aren't familiar with these types of fabrics, what was the weight of that tarp?
Okay, so your typical 6x8 sil nylon tarp is going to weigh in the range of 7 to 9 ounces, and our 6x8 Cuban fiber version was 2.9 ounces.
That is amazing, and it really gives you an idea of if you can extrapolate that into a pack or a shelter, you can see how much the weight savings are here.
Yeah, it was pretty remarkable, actually. But by about 2005, there was a thriving make-your-own gear community, and they were making a whole bunch of stuff out of Cuban and then posting their designs and construction techniques on the backpackinglight.com forums. And I really feel like it was these guys that were pushing the edge of Cuban fiber applications for the outdoor industry back then. One of our forum members in particular, Bill Fornshell, was making some incredibly light gear with Cuban fiber. He was doing quilts, packs, ponchos, and he even made an inflatable sleeping pad. His contributions, I think, were really important at the time, and I'd like to believe that our MYOG community played some role in providing the seeds of inspiration that resulted in some of the early cottage manufacturing of Cuben fiber products back then. So anyway, in 2007, the Cuben Fiber Corporation sort of split, and the sail-making division was purchased by North Sails, and all non-sailing applications were organized under a new company called Cubic Tech. And this was the company that supplied the outdoor industry for several years. And Cubic Tech was then purchased by the Dutch company DSM Dyneema in 2015. And Cuben Fiber Fabrics were then rebranded as Dyneema Composite Fabrics, and that's how we know them today.
Cool. So now that we have some context, let's segue into our interview with the main guest for today's podcast, Wes Hatcher. Wes has been involved in Cuben fiber product development since the early days of Cubic Tech, and he's currently the applications manager at DSM Dyneema. He is the guy who has been the driving force behind DCF development and innovation for outdoor industry applications.
He's also the one at DSM Dyneema who's been supporting our cottage manufacturers and working directly with them to expand the offering of DCF products in our market. Wes joins us from the original manufacturing home of Cubic Tech, now DSM Dyneema, in Mesa, Arizona. Wes, thanks for joining us today on the podcast.
Thanks for having me, Ryan.
Tell us a little bit about the history of DCF Fabrics and the relationship between Cuben Fiber, Cubic Tech, and DSM Dyneema.
So historically, Cuben Fiber and the Cubic Tech family has made fabrics for about 15 years, probably a little bit longer. The interest with DSM, we had always used Dyneema fiber in our material and showed it to them several times. And so in 2015, they sealed the deal and purchased Cubic Tech. So we're operating now as DSM Dyneema Performance Fabrics out of Mesa, Arizona. So in the 92 America's Cup, the press actually coined the team the Cubens. The team was America Cubed. It was Bill Koch's team at the time, and he went about the cup in a bit different way. The America's Cups were all very competitive, and they all went to look into boat building and hydrodynamics. Bill actually hired a team that was into artificial ligaments to develop a new sailcloth. If they could bring the weight of the sailcloth down, you have lower weight aloft, allowing a higher riding moment, and it allows the boat to go, straighter, faster. So he hired this team of really smart individuals, a couple of them, Heiner Meldner and RJ Downs, who helped, win that cup in 92. After the cup, team dissolved, the guys were able to purchase the patent and get the IP back and continue to run in Arizona, closer to family, making different types of sailcloth and other aerospace laminates.
Great. So what we're talking about here is Cuben Fiber Fabrics it was a family of different types of fabrics, just like today, I guess we'll refer to them from here on out as DCF or Dyneema Composite Fabrics. It's a family of fabrics, right?
Yeah, we're more of a process rather than one material. We spread out Dyneema fibers. We apply certain amounts of proprietary adhesive to them, and then with that adhesive, we can then bond on different face fabrics, whether it be a film, a fabric, a TPU. So we're more of a process. We make things, and we'll dive into some of the other ones in a minute, but we can do everything from breathable to weldable. So we can make, just your run-of-the-mill backpack fabric, have some polyester woven on the face, or you can leave it off to shave weight. So it just depends on what you're trying to get out of the article.
So when you lay down these Dyneema fibers, you're not doing it in a woven pattern. They're loose, monofilament thickness.
They're strictly non-woven, and we'll use the term precursor. That's what we call it. So we form this precursor, and the precursor is the fiber with the adhesive together. They are laid out in static, so nice straight single strands. Well, many strands butt next to each other. And we do it in, strictly non-woven. So we have a 0 and 90 degree layers, what we refer to it as. The industry, refers to it as warp and weft. But because we don't weave those, we kind of reserve our own terms, 0 and 90.
And what's the advantage to the fabric being non-woven?
So the main advantage is no crimp. When you weave a fabric, you have crimp in every single turn of that fiber. When you are going to load up that fabric, you have to pull all that crimp out first before it actually reaches its working load. So with these materials, with the composite fabric, you're at your optimum working load right away. You don't have to pull out any crimp or load up the fabric. So when we say it has a working strength of this, it means you're immediately using that working strength. It doesn't have a stretch and elongation.
And maybe just for the layperson, can you just describe what you mean by crimp?
In layman's terms, the best way to explain it's like a hair crimper. If you peel fabric apart and start to peel out the little fibers themselves, it looks like it came out of a hair crimper because of the way they tightly weave it together to keep it from coming apart, one, and two, to get it waterproof quicker. You induce crimp into these fibers. Also, there's heat involved. They heat set things. So you can imagine it as if it was a hair crimper in it. And it basically puts a bend, about every millimeter, depending on the denier of fabric. It puts a bend in it and it locks that in place with heat and pressure. With something like a sil nylon or polyester, same, that crimp has to get pulled out before that fabric is actually fully loaded and doing its job.
So when you mean doing its job, what you're essentially talking about is why fabrics stretch. Is that correct?
That's one of the reasons fabrics stretch. Now, the other problem or the other inherent nature is the fiber's makeup. Dyneema only stretches 3% before it breaks. So if we have a fiber that's spec'd at, a couple hundred pounds, if you load it up to its working load, it only stretches 3% before it breaks. Other fibers stretch 30% before they even begin to reach their optimum working load. So it's more about the fiber's chemical composition than it is about the load itself.
Can you just kind of go through a blow by blow of what the core performance properties are that make DCF different from something like a coated nylon?
Yeah, so the properties that kind of set us aside or apart are, the no stretch, high strength to low weight ratio, and then no water absorption. So Dyneema floats on water. It's inherently hydrophobic. The films that we use really don't retain a lot of moisture either. So we use different surface fabrics. We don't need to employ a DWR on our fabric in order to do the same thing that you'd get out of a DWR backpack. We don't need to do that because the underlying layers of Dyneema and film are completely watertight. So that's kind of what sets us apart from current industry available, fabrics.
I mean, you say high strength to weight, but it has a reputation for not being very abrasion resistant. Can you speak to that?
When you take this amount of fiber, again, it's a very low amount of fiber, and you spread it out very, very thin in static, now we're susceptible to snags and cuts. There are forms and versions of Dyneema that are very abrasion resistant, but they're going to be like a woven 100 denier Dyneema. And the problem with that is then the price goes up exponentially. We aren't able to pull lower denier fibers very economically. We pull very large scale fiber very economically. So 2640 denier or 1760 denier, those are the ones that, we are able to spread down to very, very thin levels to achieve these fabrics that we're using. And when you do spread them, we're talking filament by filament. So our typical tarp and tent, offerings, the filaments are basically like spiderweb or less than human hair spread out next to each other. And they're constrained in place by their opposite direction of fiber and the adhesive present. And so that's where if you place something hard in a bag, like say your stove or crampons are inside of a backpack and you stem up a wall, you're going to wear through that portion no matter what. You will also do that on a normal backpack, but because those bundles of fiber on a normal woven product are able to move a little bit, they can kind of conceal the fact that they're being abraded.
Great. So DCF fabrics consist of Dyneema fibers, and then there's some kind of film applied to those fibers. And then optionally, this resulting construction is sandwiched to a face fabric for additional strength and durability properties. Is that fair?
That's correct. We're basically encapsulating the high strength fiber within the proprietary adhesive and the face films and or fabrics to do whatever job it needs to do.
That adhesive film that you're using to sandwich the Dyneema fibers in is yeah, I know you guys have used Mylar based adhesives in the past. Are you is this an engineered property, or is this a proprietary thing that's common to all DCF fabrics?
The adhesive that bonds everything together is proprietary. We can't get too far into that, but what I will say is that the Mylars and they're polyesters, basically PET, polyethylene terephthalate. Those are films that we put on the outside. So that's not something that you're using to bind everything together. That's simply there to protect the Dyneema fiber from getting snagged. Because the fibers are so strong, if you have it exposed, it snags. It doesn't just break. It'll peel that fiber out of the laminate. So we use the Mylar films on tents. We use on backpacks. We use a Mylar inside and a polyester woven bonded to a film outside, so that each thing is kind of tailored to its use.
Great. So are you using anything else besides Mylar in these constructions, or is it predominantly Mylar?
For the lighter weight stuff, we're predominantly using what is trade named Mylar. We don't actually use Mylar on everything. That is a trade name, kind of like Velcro. So we try to stay away from it a little bit. But we use TPU. So we use some hot melt TPUs on some surfaces. We use PU on other surfaces that we don't want to heat weld. You can still weld those things with hot air and RF welding. So we use many different materials. We use nylon face fabrics for really heavy stuff for the military use. So 500 denier, PU coated nylon can be used on some faces. That's obviously way too heavy for the ultralight backpacking realm that we're discussing, but it shows kind of our latitude that we're able to bond to many surfaces.
Is there a higher environmental or energy cost to DCF than comparable fabrics?
No, I'd say we're one of the lowest cost high strength fibers. In fact, that's a proven study. We can get you guys some numbers on that, but we're the greenest high strength fiber. So we have the least amount of input into the fiber itself. We just have a very few parts of that process, no wastewater and no real waste in itself. We draw the fiber after it's pulled, which was where the strength comes from. So we don't have any like carbon fiber. You have to cook it and you need a ton of water present to cool off those, processes. So we start with the green fiber. Again, we bring it on over here to Mesa and we have no wastewater, no dye lot, no dye stuffs. We really manage our waste well with the EPA and, local agencies. So we produce one of the greenest things out there. Now, if you compare that to a woven polyester that then you have to, or a nylon, that you have to then coat and then turn it over and coat it with silicone on the other side, those go through a lot of processes where there's excess waste left over, and it's not a pretty thing when you have to do that many steps to a fiber to get it to be waterproof. We start with ingredients that are inherently waterproof. So
if you're laminating a woven fabric to the DCF construction layer, how does that play out in terms of what you were talking about earlier with crimp and stretch?
Basically, the Dyneema fiber content is the one that's bearing all the load. Because it loads up first, it bears all the load. And what happens is that you'll actually see that the Dyneema break, but only after you reach its breaking strength. So in the backpack weights that we're usually using in the industry right now, that's 190 to 250 pounds tensile strength per inch. So really, you're not able to load a backpack that much. Now, you might point load something or throw it off of a cliff and it will reach those loads. But for the most part, the breaking strength is not exceeded in the Dyneema fiber portion. What we utilize the polyester for there is abrasion resistance. It adds, Dyneema is very abrasion resistant itself, but in order to weave a 150D Dyneema, it would be priceless. It would be way too much money on the face of your fabric there. So we use polyester wovens to be an affordable, face fabric that can handle some of the elements, whether it's, abrasion or moisture.
Yeah, that makes total sense. That's a good segue into waterproof breathable fabrics that you guys are doing. I know you're laminating DCF onto event and various constructions that provide a breathable fabric. So is the breathability governed by what you're laminating to, like event, or is it governed in part or whole by the DCF construction? Do you have control over that in your guys' process?
Yeah, there's many factors involved. Obviously, the inherent breathability of something like a microporous event is already really high. The trick is to not quell that or to not impede that flow or that air permeability. And so what we have done is we haven't done a whole lot to manipulate the process itself. I mean, we still use the similar parameters in construction. It's just that inherently we have what you'd look at as, again, in layman's terms, it's like a window screen. There's enough gaps there that don't impede the air movement that allow us to make a breathable membrane product. And we can use other microporous membranes out there. There's many of them right now. Polycarbonate, there's PU, there's polypropylene, there's even polyethylene microporous, and we're able to bond to all of those very well.
So what performance benefits does that give over just those fabrics in and of themselves?
I mean, we're taking something at the lowest weight possible and making it the highest strength. So right now, about the lowest that they'll bond on a waterproof breathable is a 10 denier. It just doesn't have any tear strength. And what we're able to do is bond many fewer fibers. So like nowhere near that. We don't even refer to our laminates in denier because it's just not the same scale. We can put down just a couple fibers in the same space and exceed the breaking strength either by double or half the weight. It's either or. You can have one of three things. You can either have stronger, lighter, or more abrasion resistant. So we try to achieve a couple of the former.
Let's talk about an actual product here that uses this waterproof breathable construction. Hyperlite Mountain Gear has a product called the Shell. It's a DCF fabric based waterproof breathable rain jacket. It weighs about 6 ounces and it costs $450. So it's not unique in terms of its weight. There are other jackets similar to it that weigh about that amount, nor is it unique in terms of its cost. I mean, if you look at an Arc'teryx jacket made of Gore-Tex Pro Shell or something like that, I mean, they enormous amounts of money. So how do you feel this jacket serves the market, and what is its main performance benefits that the user's getting at this price and weight point?
Yeah, I think a couple benefits out of the Hyperlite Shell is the pack size, the weight overall. Again, we've touched on, but being able to fold that flat and put it in your back pocket and take it with you really says a lot. The extreme breathability of that material. I mean, I've worked with that package for about 6 years now, and being able to stop on a break while backpacking and put that on and have your back almost completely dry by the time you start hiking again is pretty substantial. So its properties, I mean, it's moving moisture a lot quicker. It's less material there that can get wet and need to be, DWR'd throughout its life. It's just a real, kind of minimalistic package. So low weight, I think, and pack size are my favorite things out of that. But the tear resistance, again, is kind of the main underlying. We hope that we never have to deal with it, especially if you're, out completing a project or something. But really, tears won't propagate in that material. You might cut a little hole or snag it on a limb or something, but it's not going to propagate, whereas a normal 10D nylon would just completely zipper open and tear.
Yeah, I've been reviewing this jacket for over a year now, and we're getting ready to publish a review. In fact, that review might be out by the time this podcast drops. But the thing that was really noticeable to me is, no, it's a light fabric. It's not immune to puncture or tearing, but yeah, those tears are small and they do stop. And for a jacket this light, that is definitely one of the unique features that I have noticed.
Yeah, being able to patch it too. I mean, you don't want to come right out and say that to your customer, hey, you can put duct tape all over it, but in a pinch, those things stick very well. You barely have to wipe it off and it bonds well. So
yeah, I use Tyvek tape to patch almost everything I own with DCF, and It's incredibly light, incredibly thin. Yeah, it's amazing stuff, and it sticks to DCF better than almost any other fabric I've used.
Well, Ryan mentioned the cost of that jacket. Can you tell us what makes DCF more expensive than other outdoor performance fabrics?
We are a hand-built product. I mean, we're handmade in Mesa, Arizona. We're mechanizing things daily, but there's only so much, investment and infrastructure you can put in one place. So when you think of a hand-laid race car or a mega yacht, those things, they're laying those carbon fiber plates by hand. And we're actually doing that here as well. So until, advances happen in our construction, we're still probably the driving force of it is labor. The Dyneema fiber content isn't such a big driver in the cost, but again, it's the labor. Now that also has to be said for the cottage manufacturer. These guys are making these in small batches. They're cutting these by hand. There's other avenues to get to the end product a little cheaper. Now we have seen, a similar fabric used in a Burton jacket. It had a fairly high price, but it was a pinnacle piece for the Olympics. So we're slowly gaining momentum into the market and getting, higher adoption in larger and larger companies. So I think over time we'll see the prices come down a little as construction and manufacturing kind of starts to get in line with current practices.
There's some speculation that, especially since Cubic Tech was purchased by DSM Dyneema, that demand for DCF fabrics has gone up quite a bit, and that there's been some issues with your guys' ability to meet that demand. Is that true? Is there some truth in that, or are you guys doing fine?
The truth of the matter is we're rocking along here. We've never seen, we're having record months as far as output. We're seeing record months in sales and just overall, in general, the morale on the team is high. We opened our second shift for the first time in a couple of years. We're definitely not. We're not having trouble meeting anything. I would say we're handling it in stride. When we're all as a team, we've got many moving parts, and we're all doing very, very well at the moment.
That's great to hear. I'm hoping that DCF becomes accessible to as many manufacturers as possible, because you guys have kind of dialed in the innovation side of the fabric. I'm really hoping to see that there's some more innovation in product development now as well.
Yeah, our eye is always on product development. Unfortunately, you can't hire enough engineers to keep you busy there. So we're doing what we can with what we have, and we're listening to our customers with what they want. I think we're all growing together. That's the main thing to note, is that we're not just putting stuff out that's not requested or asked for. And I think, DSM Dyneema being the parent, they want us to really focus. They want to do high volume in order to bring these prices down for everyone. And so until those two things happen, innovation it's always there, but it's not the main driver of your business.
Our listeners are really familiar with the use of DCF in ultralight shelters. Tell us about the technological advances in future versions, or what you're working on right now that might make its use in shelters even better, and why.
I personally really enjoyed a development we did a couple of years ago. We put a really light 1mm TPU on one side of a floor, and that allows you to put that down towards the rocks, basically, and really increase your puncture resistance by a lot. It does add an ounce. It's, 1 mil of TPU adds 25 GSM. But what it affords is 1, puncture resistance, and then 2, weldability. You can now turn this floor over if you should so choose, or put it on a different item and heat weld things to it at a low temperature. So you can weld this TPU at about 265F for a minute, and you got to just let your imagination run wild there. You can do a lot more with this fabric than we used to be able to at that weight. TPU is getting lighter and lighter, but then it makes it harder for us to handle it here and apply it. We don't do a knife over roll coating, so we're never going to be in that realm where we can get these really light kiss coats on things. But for the most part, that was a good development, I think, for the bivy and tent floor world, that we were able to do at a pretty low weight. If you compare it to some others' weights out there that they're using on floors, it's pretty similar, because you don't need tensile strength on a floor. You're laying on it. what you need is puncture resistance. So that's one that I'm pretty happy about for the last couple of years.
The development of weldable fabrics, and obviously you guys have quite a lot of control over the adhesive and the film you're putting on to encapsulate the Dyneema fibers. Is there any hope for a DCF fabric pack raft in the future? And does that even make sense?
I think we've already got weights present that'll do the job. The one main difference, we jump back to our first question, and that's stretch. When you have a 210 coated nylon, it's going to take some, it has a little bit of dynamic stretch. And so when you do scuff across a rock or bottom out, you have some give there. When you take a CT9 Dyneema fabric, it's kind of laid out in static. Those fibers are doing their job right from the start. And if you bash it on a rock, you might be able to puncture through. So all in good time, I think we'll be able to come up with some better versions that maybe have a little thicker surface coating on the outside, maybe a little thinner TPU coating on the inside to allow it to be, lap joint weldable. But I think we're just looking for a company right now to experiment and adopt that strategy and really push that to the next level. We did a really burly reinforced boat. That was about 375D coated Dyneema, but that was not coated with anything weldable. And so the difference being there, that was a sewn construction with a bladder. That boat was made to be pretty much indestructible.
Let's go back to shelters for a second. Locust Gear put out a dome tent that had geodesic DCF panels in it. And it looks like a beautiful design. It looks well constructed. The panels are obviously cut to a high level of precision. This has been one of the criticisms from talking to other cottage manufacturers about DCF, is that because of the lack of stretch, it's not very forgiving in the construction. What sophistication needs to happen? What innovation needs to happen, at least in the cottage industry, for them to apply such a low stretch fabric into shelter design, especially if they go into something like a geodesic panel that the Locust Gear dome uses?
There's a little bit of misconception with that. There is such thing as bias stretch in all of our material. So what you lack in patterning control, you can make up with in bias stretch. That particular item, as soon as those poles go in there, it will find equilibrium and make its own pitch kind of nice and tight across the backbone of those poles. As in regards to patterning other items or other panels, like you said, geodesic, there's a certain amount of manipulation that has to happen to existing patterns. So you can't just take a sil nylon pattern and immediately cut it and expect to have a beautiful Dyneema composite tent. We've seen a really good example lately with the TarpTent. They added some extra catenary in the lower end of the fly, and what they achieved was a much tighter, nicer pitch out of that. And they've also added, I think, maybe 2 or 3 inches to the actual length of that sidewall to get it down closer to the ground. So it's just a matter of not taking some pattern that exists and copying it. It's really designing for the project.
Yeah, you bet. So we have a variety of different applications in the outdoor industry so far with DCF: shelters, stuff sacks, rain gear, pack rafts, backpacks. Do you see yourself emerging into new product markets anytime soon?
We've always been dabbling in aerospace, so the sky's the limit there. I can't really talk about too much what's going on there, but the advances that are made for that realm are going to help everybody, obviously, either whether gets our fiber spread thinner or gets the fiber strength up. So there are other versions of our fiber out there that have lower creep, higher strength. So those things will trickle down over time. I can't say that they're going to just immediately make it into backpacking. Obviously, we need to keep the price kind of in sight here with these materials. I think we'll see more protective gear in the future as well, just whether it's a shin guard or rash guard for working with dogs, or there's all kinds of realms that we just haven't been able to touch on because we're such a small team. It just takes an early adopter to kind of pose the question to us. Once we kind of look internally and see if there's a business case, then we really can push some new realms with this material.
Do you think there's any applicability to use DCF fabrics in footwear?
Yeah, we've actually had a couple cycling shoes made with Dyneema in several different form factors. So one was an applique over the top of an existing non-woven material, and what that did was it made it no stretch. The other version was a Dyneema mesh sandwiched in between TPU. So those are the specialized S-Works 6 and 7. They're out now. And we're working to get it into other areas. As you know, footwear is a pretty high abrasion area. So we're looking into woven and non-woven combos. Nothing really likes to stick to Dyneema. We have a proprietary process that allows us to coat and bond well to the Dyneema. So we're utilizing like woven Dyneemas bonded to our non-woven, and that allows us to get kind of into some more footwear that you wouldn't normally see us on.
All right, Wes, thanks very much for taking the time to have a conversation with us today. We learned a lot. I hope our listeners do as well. And I'm excited to see what's in store for you guys in the coming years.
Yeah, thanks for having me, Ryan. I hope we cleared up some, stuff out there, and your listeners will definitely benefit from this. And we'll keep you guys posted on what we're working on in the future.
Well, that was a really cool interview. The more I learn about some of the inner workings of our industry, the more questions I have about how it works and what's possible.
Okay, so let's structure the rest of the podcast around a list of questions related to Dyneema Composite Fabrics that our audience may be interested in. You and I can just chat about the questions, and we'll pepper in some excerpts from the rest of our guest interviews.
That sounds great.
What's a question you get about DCF that perhaps reflects the most ignorance about these fabrics?
That's an easy one, actually. The question is this: are shelters or packs a better application for DCF? And in order to answer this question, I think we have to realize what DCF is and what it is not. So let's talk about what it is. It is a laminate. So for the most part, it's designed to be used as part of a sandwich that involves the DCF laminate, which includes Dyneema fibers and the film that encapsulates them, as well as other types of coatings and treatments, and or the bonding of the laminate to an entirely different fabric, which might include a woven nylon or polyester or some other woven fabric. The DCF laminate is not by itself suitable for any ultralight backpacking application. It's simply too thin and too fragile to be puncture or abrasion resistant. So at bare minimum, the DCF laminate needs to be coated with something. For example, a layer of polyurethane to make it more puncture resistant. A lightly coated DCF fabric can then be used in a stuff sack or shelter application where abrasion resistance isn't really needed. But you can also take a DCF laminate and bond it to a more conventional fabric, such as, let's say, a tightly woven polyester. And now you have a much more puncture resistant and abrasion resistant fabric sandwich that's suitable for applications like backpacks. So in summary, the answer to the question is yes, it's suitable for whatever application you want. But as a product designer, I think you need to have the intelligence and the talent required to use the right type of fabric construction for each application.
And you mentioned there the durability, the puncture resistance, abrasion resistance. There's really been some criticism about the durability of lighter DCF fabrics. And we have some additional thoughts from a few of our other guests. First, Glen Van Peski of Gossamer Gear.
Say you're going to build a $1,000 shelter, you can explain to most people, hey, this is fragile fabric, you have to take care of it, don't do this, always do this. But still, if someone pays $1,000 for a shelter, they're going to have some expectations, and it kind of ups the ante as a manufacturer if someone blows out their $1,000 tent and they call you up and they want a new one. That's a big hit.
Next, Joe Valesko of ZPacks gives us his take on DCF durability.
The material we use on our backpacks is kind of a hybrid DCF. It has the same kind of membrane with Dyneema fibers on the inside, but then it has a layer of polyester material on the exterior. And we switched over to that a couple years ago rather than going with just the straight DCF fabric. And the main reason is that polyester on the outside, it protects the fabric from like UV radiation. It protects the fabric from getting scuffed on rocks and things like that. So the exterior, the polyester itself does also get scuffed sometimes. I mean, that's usually the biggest problem or the biggest issue I'll ever run into is maybe if I slide down some boulders or something and slide my backpack against some rocks, it'll get scuffed up a little bit. But it's nothing that's not manageable. You can always put some repair tape on the inside of the pack or that sort of thing. And that actually is one of the best things about DCF fabric, I think, is how easy it is to repair, just because tape sticks really well to it. So if you ever do have any issue like that, you can just put some tape on it.
Graham Williams of CiloGear had a different experience when using DCF in packs. We'll hear from him next.
So I'd say this about durability of DCF in backpacks. We tried 7 different materials straight off of their shelf in 2005 to make small backpacks. We hit upon a good material, made a pack out of it. It came back from one trip trashed. In 2006, we revisited it and we had them invent what a lot of companies are now using. I see it around more, which is we had a 200 denier and a 100 denier Dacron or polyester that they sourced from a sailing company, and they were putting a DCF scrim on the back of it. That stuff, our first attempt in 2007, and you can actually see it on the internet on climbing.com if you look at Kelly Corda's climbing Cerro Torre for the third integral ascent. Anyway, that pack lasted one trip as well, and we discovered a lot of things about construction in that we hadn't been quite aware of. And the third type that you could consider is a woven Dyneema with a DCF scrim on it. That one's really challenging because it turns out that Dyneema doesn't want to bond to anything else, and having a durable bond in a humid environment where you might have freeze thaw like the mountains is really challenging. And to have the durability that you would want to see, like what we've achieved with the woven, non-woven DCF that we use is 5+ years of Himalayan expeditions, 3 to 4 Himalayan expeditions per year with these packs. It's absolutely unheard of, and there's nothing else that's even close to that in terms of durability.
Here's what Mike St. Pierre of Hyperlite Mountain Gear has to say about durability and gear maintenance.
I mean, we're always in the hunt for new fabrics that will hold up to the demands of our customers. But I'm also a firm believer in you get what you pay for. The way I look at this is, you're basically carrying your house on your back on these, backcountry trips. And to me, I want the best possible products that I can. I mean, ideally, these lightweight products allow you to get deeper into the backcountry faster. And once you're out there, I mean, you're kind of out there, and I want to make sure that I have solid products that are going to hold up to whatever the demands are that are thrown at me. We built some canyoneering packs for canyoneers, including some of the rangers in Grand Canyon. And, canyoneering in Grand Canyon National Park is probably one of the most demanding on abrasion resistant fabrics. And I mean, the limestone out there from, the erosion is basically like razor blades, little needles and razor blades. And I mean, it'll just chew up anything. And, we're finding that fully woven Dyneema fabrics, laminated back to these kind of films, these Dyneema films are holding up better than any canyoneering packs that have been built and used out in Grand Canyon. So again, I think it just really, I think some manufacturers could do a better job of matching the fabrics to the products and the end use of those products. And just because you're the lightest product out there or it's the lightest product out there doesn't mean it's going to hold up. It's imperative that you respect the products because you are so remote. If you beat something up or, don't treat it with the care that it deserves, you can ruin a product. And what are you going to do when you're out there, 50 miles or 100 or 200 miles out in the middle of nowhere, So I don't know. I think it's, I'm glad to see people are out there on the trails and getting their feet wet and, just being in nature. But, a lot of this comes with experience and, just time in the saddle.
So how about shelter floors? Lots of controversy and debate about using DCF in shelter floors. Is that a valid criticism?
Well, again, let's match the fabric construct to the application. So fabrics used for shelter floors, they just need a durable coating to minimize puncture resistance. And there are plenty of fabric constructs within the DCF family that can accomplish this. Now, the primary advantage of DCF, which is its strength to weight ratio, isn't really needed in a shelter floor. So some of the criticism is geared towards using a very expensive fabric in an application that may not warrant that cost. But if you consider the two key performance features of a shelter floor, which are waterproofing and puncture resistance, then DCF is definitely worth a look, especially since waterproofing and puncture resistance can be achieved at a lighter weight than with any other fabric out there. And then you have the ease of repair of DCF, the lack of slipperiness. Sil nylon is a horrendously slippery floor, and sleeping on DCF is a much more pleasant experience. So it makes a pretty good option for a shelter floor, I think. So in short, maybe some of the criticism of DCF for use in shelter floors comes from people. They're either trying to tell a story that isn't really there, or maybe they're not aware of the options available within the DCF family to match the fabric to the application.
So here's what Henry Shires had to say about shelter floors.
The Dyneema flooring that we're using is the 1 ounce variety. And in our testing, playing around with it, we feel like they're pretty comparable. The 1 ounce, I don't worry about abrasion and stress and strain so much on the 1 ounce Dyneema. I think it compares pretty well with the 1.5 roughly ounce Sil nylon that we're using. At the end of the day, though, it's really about the trade-offs between, let's say, carrying a ground sheet protector, which would pretty much guarantee that you're not going to end up with abrasion or holes in your floor over a long period of time, and not carrying it, and then just dealing with the consequences, which is that you might need to occasionally patch your floor.
And Joe Valesko.
The way we get around that is we make all our shelter floors with 1 ounce per square yard material. The membrane that's made of is twice as thick, so it's basically twice as thick as the canopy material. And by using the thicker material, it's better at abrasion, and it's good. We really haven't had any trouble with our shelter floors. And even if somebody did, again, the fact that you can just cut a little piece of tape and stick it on the floor to fix a hole right in the field on the trail, that's a really big benefit. Whereas with Sil nylon, that's going to get punctured just as easily, but you're not going to be able to fix it unless you're carrying a tube of silicone or something like that.
And Mike St. Pierre.
Through my experience and 10 years of using these fabrics, DCF is hands down my favorite floor fabric. It's truly waterproof. I've set up shelters, in depressions in the ground, maybe because that was the only place that we could put a camp. And I've laid in puddles with these fabrics, testing them, and slept all night and woke up completely dry. To me, DCF is nowhere near as slippery as Sil nylon, doesn't feel soggy or slimy when it's wet, stronger than Sil nylon, and it's considerably more waterproof than Sil nylon.
So it seems like a lot of the manufacturers that we talked to all had different ideas about the best ways to construct with DCF. Sewing, bonding, by which we mean gluing, sewing then bonding, bonding then sewing. What's the best? Is there a best?
Well, I think we're going to hear from Mike that it depends on the application and the location of the seam within a product and how much stress that seam is undergoing. The main issue for me is that you can't just sew it. And I know in the early days, that's all we all did is we just sewed it. But these products failed spectacularly if you just sew a seam that is then subject to stress, because the threads cut through the DCF fabric and the seams they explode. So we know that sewing by itself can't be done. Now let's take a look at what is probably the most elegant construction, and that's bonding the seam only. And there are a few products that use this application. Locust Gear comes to mind. I know they have shelters that are bonded only. The risk with bonding only is that these glues are temperature sensitive. So in either very hot environments or very cold environments, you could get a seam failure, and then you're back to trying to repair with tape. And, you can't really repair a seam that's undergoing stress with tape. You need something stronger. So then we're resorted to sewing and bonding. And then it's which order? Do we sew and then bond, or do we bond and then sew? And we'll hear from manufacturers that do both things. The advantage to sewing and then bonding is you get a much prettier construct. It's a more aesthetically pleasing look to the shelter or whatever you're doing, because you're actually hiding the stitches. The other advantage is that if you bond over a seam that's been sewn, some of the glue from the bond can then permeate into the seam and strengthen it. The risk I see with sewing and bonding is that if the bond comes undone as a result of, environmental conditions, and the tape falls off, then you're left with a seam held together by sewing only, and then we're back to square one, and the thing could lose quite a bit of its strength. So intuitively, bonding and then sewing sounds like the most durable to me for a seam in the field that has the risk of that seam tape coming undone. Because if you sew through the bonding tape, then if the bonding tape comes undone, you still have the strength of the bonding tape holding at least the sewn seam together. But you're not taking advantage of the glue from the bonding tape strengthening the seam. So let's hear from our manufacturers and see what they do. I'm very curious to know how their opinions differ.
Okay, let's start with Henry Shires.
So our typical, our sort of process here is that we sew and then bond. You need to join two pieces of fabric one way or the other. So bonding alone leaves open the possibility that if the bond fails, then the tent falls apart, right? So which we haven't seen happen in practice, but it is a chemical bond, and polyurethane bonding, which is essentially what it is, will eventually break down. So we feel like it's better to sew first and then bond. And the advantage of that is it not only strengthens the fabric, of course, through the bonding, adding the additional heavy layer over the top of your seam, but it also, of course, stops the water intrusion, which is really what you're trying to get at initially. Is sewing holes in any fabric opens up water penetration places, so you have to cover those up.
And move on to Joe Valesko.
Well, we do sewing. We sew then tape, and the reason for that is over the years we've tried a bunch of different adhesives, and every adhesive has its strong points and its weak points. Some of them, if they get too cold, they get brittle and they come off. Some of them, if they get too hot, they start to ooze or slide. Some of them just wear out over time. And so taping is great, but I don't want to put 100% of my trust in tape. So the reason we sew then tape is just in case anything ever happens to your tape, your tent's not going to fall apart. You still got that sewn seam holding it together, because it's really easy to replace tape or fix tape. But if your tent falls completely apart, you're kind of out of luck if you're out in the wilderness with it.
Now, for a different take, let's hear what Mike St. Pierre had to say.
We use all these techniques. I guess it just depends on what the product is and where it's going to be going.
And finally, we'll hear from Graham Williams.
We did about 1,800 pull tests with different types of DCF when we were using it in 2005 and 2006 initially, because we really wanted to be able to design the best seam. And we worked with an engineering school in New York City and American Ifrid thread company and a couple of other glue companies and other people to really scientifically analyze the best ways to do it. And we found that it was a pretty wide open stitch pattern with a particular type of needle and then bonding it. You could use a PSA, but we found that the longest term most efficacious construction was using a glue that would bond to the surface of the seam, because really the problem is seam spread. And I'm sure everybody who's familiar with DCF has seen the dreaded seam spread, where it just starts pulling through the material.
Well, let's talk about some of the main alternatives to DCF. What are they and how are they different?
Well, DCF's primary benefits are going to be its tensile strength, its lack of stretch, its waterproofness, its ease of repair. But DCF is not without its disadvantages. It costs a lot of money. There's some technical knowledge required in matching the right fabric to the right application. And if you're building shelters, there's this lack of stretch. And I mentioned that as a benefit, but in our interview with Henry Shires, he noted that there is some challenge in building shelters out of material that does not stretch. So it requires more manufacturing precision, and that's going to in turn require that the manufacturer has the skill required to design, cut, and sew panels to a much higher degree of precision than with more forgiving fabrics like sil nylon. So sil nylon is the main alternative probably in shelters. It's cheaper, it has a lower strength to weight ratio, but it does have better stretch, and it's much easier to build a shelter out of sil nylon than DCF. There's some new fabrics on the market, sil poly being probably the main one that is being looked at by shelter manufacturers. It offers some of the same advantages of sil nylon, but its lightest versions are lighter than the lightest versions of sil nylon, so there's some weight to be saved there. But it's less waterproof and not as strong, so there's always these trade-offs. And sil nylon, sil poly, they're going to be the two main competitors to DCF in shelters. In packs, the main competitors are any other pack fabric that we've used on the market. And we'll hear from some manufacturers about the applicability of DCF in backpacks. So I'll save the discussion for that. But in general, the use of DCF in packs is going to depend on the bonding of the DCF film to some other fabric like a woven polyester or woven Dyneema.
Well, let's see what our manufacturers have to say about alternative fabrics and competition for DCF. Henry Shires starts us off talking about sil poly, then moves into some thoughts about the future of DCF.
Yeah, so sil poly is an interesting fabric. One of the things that we always look for in trying to figure out what's the best fabric for the shelters is it becomes especially prevalent on large panel tents and on tents where it's necessary to cut seam lines, diagonally through the bias. So fabrics stretch in different ways depending on how you pull on them relative to the way that they're constructed. So on a stretchy fabric, inherently a bit of a stretchy fabric like sil poly, it depends how you pull on it. So it'll stretch it in a different way depending where you start and where you end, where those stresses are. And in our playing around with sil poly, it is a bit stretchy, which allows you to do things that you couldn't otherwise do with DCF, which is a good thing. It moves a bit more in wind, especially as the panels get larger. At some point, I think to me it feels like it becomes a bit unacceptable for large panel tents for how much it can move around in the wind. The upside to it certainly is it has extremely low water absorption, which is nice. Weight wise, it's somewhere in the middle. It depends on which sil poly we're talking about, but it's not DCF, and it's at or less than the weight of the sil nylons or the PU fabrics of the world generally. So that part's a good thing. And certainly the cost is way back down closer to fabrics that we're using now typically. So that's a huge benefit, and it allows you to come up with a tent that has some benefits over, say, a nylon fabric, but without the massive cost increase of a DCF. DCF's not going to last forever as sort of the end fabric. I mean, I think we all know this. At some point, whether it's in my lifetime of making tents or not, at some point we're all going to be dealing with just few nanometer thick fabrics made of carbon in one way or another. And it's all going. There will be some revolutionary technological advancement in fabrics that'll make these current level of fabrics look like, wow, they were living in the dark ages back then.
Next, Glen Van Peski compares his customers' needs with his personal preferences.
Well, I mean, the fabric that we have custom manufactured for our shelters is 30% heavier than the DCF, at least that we were using for shelters. And so that's a hit, depending on the shelter, of a few ounces. It's immensely stronger. It's way more durable. And it can be sewed with conventional sewing techniques and seam sealed with conventional equipment. So, we think for the 30% hit in fabric weight, that the other benefits are worth the trade-off for most of our customers. Now, for me personally, I'm going to go with the DCF for my gear.
Joe Valesko isn't a fan of sil poly.
It looks like the lightest weight sil poly that I could find is being sold by Ripstuff by the roll. They claim it's the lightest, and it's 0.93 ounces per square yard. So the DCF material that we make our tents with, the default material, is 0.51 ounces per square yard. So we're still almost half the weight. Now on something like a tent, you're probably looking at 10 or 12 square yards of material. So that's probably 5 or 6 ounces of weight savings. And in addition to that, the DCF is probably going to be a lot stronger against tearing than sil poly, and you can tape it and you can seal it and all the other good stuff about it. So if there was no more DCF, if that disappeared, I think maybe sil poly would be the next best thing. But I don't think it's going to take the market away from DCF, because I still think DCF is still the best choice.
And neither is Mike St. Pierre.
I also look at sil poly as, to me, it's already a step down from Dyneema and DCF fabrics. I just don't see anything else that even comes close to these fabrics. I realize sil poly is fairly new to the market, and I think there's some major things to consider with that fabric. Is the strength and durability, tear resistance and puncture resistance. The seam sealing seems to be an issue, and overall, at least the things that I've seen in my experiences, the waterproof is even less than that of sil nylon, which is less than DCF. So it's not something that I see ourselves necessarily looking into. And we're a premium brand. We build premium products and help people achieve their goals in the backcountry. And I don't see us kind of entering into the middle of the road products or discount or cheaper products.
Okay, so let's talk about cost. How expensive are these fabrics?
Well, they're generally anywhere from 5 to 10 times as expensive as the fabrics they typically replace, which includes most coated nylon and polyester fabrics. Wholesale pricing is going to depend a bit on volume, but generally runs anywhere from $15 a yard on up to $50 a yard, depending on the construct. And you can now buy cheap sil nylon for a few bucks a yard. Retail prices are going to be higher, of course, and some of the more complex DCF hybrid fabrics, especially those that are bonded to woven Dyneema, for example, you're inching up closer to $75 or $100 a yard for some of these fabrics. So it can be really expensive,
which translates into $300, $400 a tent sometimes with some of our manufacturers. So I guess my question is, if you're looking to lighten up your pack significantly, is buying a shelter made out of DCF, worth the money that it's going to cost you?
Yeah, that's the $1 million question, isn't it? So I think Henry put this well. If your pack is already heavy, let's say it's 40 pounds, are you going to notice an 8-ounce decrease in your pack weight by taking a lighter DCF shelter? Probably not. If your pack is way down to 6, 7, 8 pounds, are you going to notice the half pound? Quite possibly. So there's a practical way to look at it like that. And then there's a less practical way to look at it, because if you really want the absolute best performance money can buy and you have the disposable income to do it, then DCF is worth a hard look, because it is going to give you a lighter product with generally higher performance than equivalent fabrics, at least in shelters.
If you had $400 to spend on your gear, but that's all you had, so you have to make a wise choice with your money, is there a piece of gear that it's more wise to spend that money on before buying a DCF shelter?
If I had an ultralight shelter already made out of sil nylon, for example, and it was working okay for me and helped me achieve my goals and objectives. I think I take the $400 and go take a trip, rather than replacing the shelter. But if I'm in the market for a shelter and I need a new one, or I don't have one already, then I would take a much harder look at DCF.
Glen Van Peski has some thoughts on this. Here he is.
Yeah, we think that for the benefits, the incremental benefit, the huge cost, and added complexity in terms of construction just don't really make it something that's valuable to most consumers. I mean, sure, there are people that want that last ounce and have a lot of money, but if we're being responsive to the bulk of our customers, it really doesn't make a lot of sense to us.
Are DCF fabrics available to cottage manufacturers starting out in their garages or make-your-own gear enthusiasts?
Yes, they are, but not directly from DSM Dyneema, unfortunately. Their minimum order quantities are fairly high, on the order of 1,500 meters of fabric. So you're talking about an investment of tens of thousands of dollars in order to get into wholesale pricing for DCF fabrics. But we will provide links to retail sources for DCF fabrics in the show notes for this podcast, and that'll give you some resources for purchasing smaller quantities.
One cottage manufacturer told us that DCF comes with, quote, exorbitant prices for marginal benefits, and that there's always someone willing to spend too much to make themselves feel better, end quote.
So what he's really saying is that DCF is a fashion product, huh?
Yeah, it sounds like it.
So, well, rather than have me answer that question, let's ask this question to our other cottage manufacturers and see what they have to say about it.
Here's Glen Van Peski.
Sounds like something that Henry Shires could have said, but of course now, because he was in sil nylon forever and ever and ever.
And Henry Shires.
Yeah, so I just want, for the record, that's not my statement. but I will say that I kind of agree in principle. So we've been making shelters professionally since 2002, and I'm not actually sure when DCF came on the market in any sort of manufacturable way, but obviously it was a few years ago. And I've just been holding off for exactly that reason, that it's always been our goal to keep shelters affordable. And DCF at roughly 5 times the price of fabric we use now, which is already roughly 5 times the price of, say, a cheap PU fabric, it just sends the end price just into the stratosphere. And so I've been reluctant, because one of my criteria has always been, would I buy the thing that I'm making? And it's never sort of passed that test on DCF products. But I would say, recently I've gotten to the point where, given the fact that there is this demand and people want products, and then I've looked at the DCF products on the market, and some of them are fine and some of them are frankly just awful from a design perspective. So I felt like, why don't we at least put something out there that I feel really good about in terms of the design of the product, and then if you want to spend the cash, go for it. And I'm still hopeful that that people will get to the TarpTent site and see the value inherent in our other non-DCF products, price, as a price point comparison.
Here are Mike St. Pierre's thoughts.
Well, this to me sounds like a manufacturer, or potentially their contract manufacturer, who hasn't figured out how to work with DCF fabrics. It could also be that this manufacturer doesn't have the cash flow to support using DCF fabrics. It requires significant cash to manage lead times in the inventory. Unless you have a good handle on that, I just don't see any way of being able to work with DSM and inventory these fabrics.
Joe Valesko certainly believes that the benefits of DCF fabrics are more than just marginal.
Well, I think there really are a handful of really good performance benefits, especially when it comes to a tent. DCF fabric is inherently waterproof. It doesn't need any special coatings or anything, which means there's nothing that can wear off of it. You don't have to reapply DWR or anything like that. Because it's inherently waterproof, it doesn't absorb any water, so your tent's not gonna be heavier after a rainstorm. You're not gonna be carrying around a bunch of water weight. DCF is made with Dyneema fiber, which has a very low stretch. And what that does for you, your tent's not going to stretch and sag overnight. You're not going to lose your top pitch over time. It tends to stay up nice and tight overnight. And again, as I mentioned earlier, one of my favorite things about it is if you ever were to get a puncture or a tear, almost any tape will stick really well to it. So we ship a little bit of repair tape with our tents. And if you don't have that, just about anything else will work. So it's really easy to fix a problem if you ever were to have a problem on the trail.
Finally, Glen Van Peski wraps it up nicely for us.
If the guy's pulling down $400,000 a year, what the hell? Buy the DCF. Who cares?
So in our interview, I asked Wes about the environmental impact of DCF. One of the manufacturers that we spoke to, Graham Williams of CiloGear, had an opposing view. So let's hear what he had to say. And we should point out that CiloGear does not use DCF in their packs anymore.
When we had a carbon scientist look at the carbon signature of the material, it was about 8 times more than a 210 denier Cordura with a Dyneema tracer in it, or ripstop. And there's just no way to justify the weight savings for the alpine environment for something that is kind of disposable in terms of the pure non-woven DCF. But here's the thing. The polyester face fabric and the Dyneema face fabric have the same energy constraint. They're both put in the same autoclave and they use the same amount of energy to make. There's no way to defend it in our eye using the polyester. There's no way to defend the polyester. I would say to the end using consumer that they have to try to figure out what they're getting, that they have to recognize that they're not all the same, and that there's little to no information to tell you about the environmental consequences of your choices. You're buying a product when it's made with these that might be incredibly environmentally consequential for a temporary solution. And I have to ask if that's really who they are.
Henry Shires has a slightly different take.
I think it is true that fabrics in general, they're all involved one way or another, are using energy to make these fabrics. So you're adding to the carbon footprint on the planet. I don't care what fabric you use.
Okay, Ryan, one final question. What are your favorite DCF products?
Well, I'm going to pick a backpack and I'm going to pick a tarp. And I've tried a lot of different DCF packs. And the one that's my favorite, and it's the application I think is right on the money for DCF, is a DCF film bonded to 100% woven Dyneema fabric. So this creates an extremely durable pack. And I want to compare it to my experience with Cordura and heavier weight Robic packs that I've used. And there's just no contest. The woven Dyneema is just incredible for its durability, and especially in a mountaineering context, which is where I primarily use this pack. And I'm off trail a lot. I'm scrambling on rock and glaciers, and there's pokey things like crampons and ice axes and whatnot. And I've been really, really happy with woven Dyneema bonded to DCF. The other thing I want to comment about, Glen made a comment about the use of DCF in packs. And he said, by the time you use a fabric that's heavy enough, there are better options. My experience is a little bit different. And it's unique to 100% woven Dyneema. Now, that I think that is true in many of the other DCF constructs. But when you're bonding it to, let's say, a 3-ounce woven Dyneema fabric, you've got a backpack that is far more durable than almost anything you can buy at a much higher weight. So that's my comment on the pack. This particular one is a large expedition pack. It's designed to carry a bit of weight, has about an 80 to 90 liter capacity. So in that application, I think a woven Dyneema DCF hybrid is a great fabric. For my tarp pick, my favorite tarp is a Solo Pyramid that's made of 0.8 ounce per square yard DCF that is a Dyneema composite film. So it has the fibers in this film, and it's sandwiched between polyester film coatings on the inside and the outside. The exact number of the fabric is CT2E.08. And I really think this is the best shelter fabric on the market. It's about as light as it can be and still be durable enough to use in a tent fabric. If you go much lighter than 0.8, you start getting into tent fabrics that can be fairly fragile. And if you have, a tent brushing against trees, or if you have a tent that is secured by rocks and maybe the rocks are coming into contact with the tent fabric, some of the lighter DCF constructions are a little bit too light for my comfort.
And Ryan, did you not give the specific name of your pack choice on purpose?
No, I'll put a link to the pack and the shelter in the show notes. The pack is from McHale and the shelter is from Locust Gear.
Okay, well, let's switch gears a little. Ryan, you have a pretty interesting story about a particular DCF application. Can you tell us about it?
Yeah, so I contacted a friend of mine. I'm going to put that in quotes. And it's a friend who was featured on this podcast. So I'll let you guys try to figure out who it is. But I said, I have an emergency and I need a fully woven Dyneema DCF product. And I gave him the specs and I said, it's got to be 46 inches long, 28 inches wide, and it's got to have a zipper at one end. And he wrote back and he said, okay, sounds good. He didn't even ask what it was. So a few weeks later, I get this product in the mail and it's perfect. And I think this is going to be the new wave of DCF products for this company. So what it is a dog bed. And I ended up, putting, padding inside. That's why I needed the zipper. It's for my dog Sierra. And as a puppy, when she was growing up, she chewed up hundreds of dollars of dog beds. And at some point I gave up and said, you know what, we need a Cuban fiber dog bed for you. And when she got anxious a little bit when she was left in the crate and we'd go run errands or something like that. And then we'd come back and her dog bed was chewed up. So this was specifically sized to fit into her crate at home. And the first couple times we came back, she did chew off the label, the brand label. So maybe that is maybe she doesn't like logos. I don't know. But she wasn't able to touch the other stuff, although we saw the chew marks on the fabric. And so eventually she realized she couldn't chew this one up and just gave up. And so now we have this Dyneema dog bed, and it's a great application. And I really think if there's anybody out there listening who wants one of these, they should email this manufacturer and request that they make them a custom dog bed. And this manufacturer should do this because it'd be a great market.
Chew-proof dog beds. I love it.
Anyway, I'll post a photo of Sierra on her Dyneema bed in the show notes, and maybe I'll link to my friend's website.
Okay. Well, there you have it. An in-depth look at Dyneema Composite Fabrics. We hope this has provided you with some valuable information. So what else is going on at Backpacking Light right now?
Well, on April 26th, we have a webinar, and it will be about DCF. We're going to talk a lot more about design, the different fabric constructions, technical performance, matching fabrics to specific applications, and an overview of products on the market. So you can find out some more information about the webinar at backpackinglight.com/webinar. So if you have an interest in either making gear with DCF or knowing how to sort out the complexity of the fabric market so that you can make good buying decisions, this would be a good webinar for you to try. We just published a review of 2 DCF products, so be sure to check those out. Hyperlite Mountain Gear produced a DCF waterproof breathable rain jacket called the Shell, and we have a long-term review of that out now. And the real highlights from this particular jacket are its durability and its breathability, and so I'll talk about that quite a bit in the review. The hard thing to swallow is that you're paying this kind of price for something that weighs so little. And intuitively, it's like, well, lighter stuff should be cheaper because there's less stuff. But again, it offers some durability and breathability advantages over most jackets in this weight class that it's worth a look.
And did you get out in some gnarly conditions to test this thing out?
Yeah, I'm really impressed with the breathability of this fabric, actually. It has breathability ratings that are at the top of its class. It's a DCF construction that's bonded to Event, which is one of the highest performing breathable fabrics on the market. So it's impressive.
Awesome. I can't wait to read that.
So the other review we published last month originally is the TarpTent Notch Lithium. We did provide an update in there based on some new things that we've learned about it, and we talk about storm and condensation resistance in that review.
And we'll put links to both of those reviews in the show notes. So now it's time for our Here and Now segment, where we share a little bit about what we're currently studying, learning about, testing, or planning when it comes to our backpacking gear, skills, and activities. So Ryan, what are you up to this month?
Well, we just launched a new trek in our 2018 Wilderness Adventures program. So this is the Whitetail Trek, and it's a new program for us this year. It's a longer duration. It's an 8-day program. We'll spend 7 of those days on the trail. It's more difficult than the other treks that we offer, and we're really focusing on expedition planning and executing an expedition. So a lot of the program is going to be performed starting now, where we take the participants through the entire process of how to plan an expedition, and they're gonna go into route research and route planning. And so I can't even tell you where we're going to go, other than it's going to be somewhere in the Absaroka-Beartooth Wilderness in Montana, and it will largely be up to them about what kind of route they decide to engineer and attempt. But generally, it's going to be a lot of off trail. There's going to be a lot of uncertainty, and there's bound to be some unpredictable outcomes on the trek. So it's a pretty exciting program for us, and I think it provides an opportunity for those who really want to step up their skill level.
That sounds very cool. I wish I could do it. Where could people learn more about that?
You can go to backpackinglight.com/treks. And I think we're going to close enrollment for that trek probably in just a few days to a week from now, unless by the time this podcast drops, it's already sold out. I know as we are recording today, there's only about 2 or 3 slots left. So we'll see if they sell before the podcast drops. If not, you have till about the end of the month to sign up. How about you? What do you got going?
Well, next week, I'm headed up into the Gila Wilderness in New Mexico for a test of MSR's 3-in-1 gravity water filter kit. So this kit includes their pocket-sized trail microfilter, which I have some experience with, and it combines it with a gravity system. So basically what we're talking about here is filling the top half of their system, which is essentially a bag, with unfiltered water, and then letting gravity push that water through the microfilter into the bottom half of the system, which has a spout for filling pots and water bottles, etc. So I'm excited to test this out because I personally love the idea of letting my water purify while I'm doing other essential camp chores. I've been chemically treating my water for the last few years because I hate expending energy, especially at the end of the day, pumping water through filters. But I did have a brush with Giardia in 2015, so I'm ready to give filtering another try. Plus, with a filter, you don't lose that spring water taste that I think is one of the best things about being in the backcountry.
Yeah, so I'm a huge fan of gravity filters, especially for filtering a lot of water. When Chase was in Boy Scouts and I was involved with his troop, we used gravity filtration systems on our hikes, and the ability to allow 4 or 6 or 8 liters of water to filter passively while you're off doing other things is a huge benefit, especially when you're trying to purify enough water for a group. It beats the heck out of sitting at a riverside and pumping for hours on end.
Well, that does it for this episode of the Backpacking Light podcast. This podcast is brought to you by backpackinglight.com. which has been providing information and education about lightweight wilderness travel since the year 2000. The Backpacking Light podcast is supported by subscription fees paid by our loyal website subscribers, and we're extremely grateful for your support. A backpackinglight.com subscription can save you time and money on your quest to lighten your pack weight, spend more time in the outdoors, and connect with a community of like-minded hikers. So if you aren't yet a backpackinglight.com subscriber, please consider subscribing and gain access to nearly 1 million forum posts, 4 million words of original content, more than 2,000 articles, and access to our Wilderness Adventures trekking program. You can subscribe online right now at backpackinglight.com/subscribe. If you have feedback, questions, or tips for our listeners, please share them via email at podcast@backpackinglight.com. We'd love to hear from you. You can download the show notes for this episode by visiting backpackinglight.com/podcast. This podcast is available on iTunes, Google Play, SoundCloud, and YouTube. Leave us a review. It helps other people find the show. Thanks for listening to the Backpacking Light podcast. I'm Andrew Marshall.
And I'm Brian Jordan. And if we can leave you with one party message, it's this: pack less, be more, because lighter is better. Happy trails, everybody.
So I shoulder my backpack, walk away from the car.